Hey guys, today we're not just gazing at the night sky. We're stepping quietly into a river of light that's been flowing for billions of years. When you lift your eyes to those scattered diamonds above, you're not seeing them as they are right now. You're seeing echoes, ancient messages, traveling across time and space to reach this single moment in your life. Every shimmer, every faint glow in that velvet dark is a memory written in light. Take a breath. Imagine the air cooling against your skin. The hum of the world fades. Around you, the night deepens, and the first stars begin to appear. Their light left home long before you were born, long before your parents, your ancestors, even before the first humans looked up and wondered what they were. Each photon that touches your eyes tonight began its journey when Earth itself was a very different place. Strange, isn't it? We live surrounded by instant messages, fast screens, live updates, yet the universe we see is forever delayed. The stars above you aren't a live broadcast. They're an ancient recording. When you see Sirius, the brightest star in the night sky, you're seeing it as it was over 8 years ago. The light of the North Star, Polaris, began its journey when the first smartphones were still being built. And when you look toward the Orion Nebula, that glowing cradle of a newborn sun's, you're seeing the light that left there before the pyramids of Egypt were built. Here's the mind-bending part. Every star is a time machine. The farther away it is, the further back you're peering. You're not looking into space, you're looking into history. And in a way, the universe itself is a vast archive, each photon carrying a page from an earlier chapter. Light is both messenger and memory. For centuries, humans thought the heavens were unchanging. A static dome hung over the earth. Then came a quiet revolution in understanding. Scientists realized that light moves at a finite speed, about 300,000 kilometers per second. Fast, yes, but not instant. It takes time to cross the vastness between stars. That delay, invisible to our eyes, means that the cosmos we observe is already out of date. The deeper we look, the older the story becomes. Think of it like sound in a canyon. When you shout, the echo comes back after a pause, a delay that tells you how far the walls are. Space works the same way, only with light. Every beam you see is an echo from some ancient moment, reflected from the deep walls of time. Now picture this. You're standing on a beach at night, looking out at the ocean. The stars are waves of light washing ashore, each one taking longer than a lifetime to arrive. Some have traveled so far that by the time they reach you, their stars have already died. Their worlds have vanished. Yet their light endures, whispering stories of things that once were. If you were to hold a telescope and gaze at a faint red speck at the edge of visibility, you might be looking at something so distant that its light began traveling toward us when dinosaurs still roamed Earth. The photons finally hitting your retina tonight were released tens of millions of years ago. You are quite literally catching the past in your eyes. It's poetic and humbling. The realization that when you look outward, you're also looking backward. The stars are not just lights, they're memories stitched into the dark. And what you see tonight will never be seen the same way again. Tomorrow, next year, 10,000 years from now, new photons will arrive, carrying new pages of that same endless story. So, as you breathe and let the night settle around you, try this. Soften your gaze. Let your thoughts drift beyond this moment. You're connected right now to everything that ever was. Every burst of light, every dying ember, every dawn that has ever glowed in the universe. Wherever you are, let the world slow down for a while. Soften your gaze, let the hum of life around you fade, and gently drift with us into tonight's quiet exploration. The speed limit of the universe is not a rule written by humans. It's woven into the very fabric of reality. Nothing, not even thought or imagination, can truly outrun light. About 300,000 kilometers every second. That's the ultimate pace. It sounds almost infinite until you start measuring cosmic distances. Then suddenly it feels slow. Imagine this. Light leaving the sun right now won't touch your face for about 8 minutes and 20 seconds. If the sun were to vanish this instant, purely hypothetically, we wouldn't know until those last photons reached us. For 8 long minutes, the Earth would keep orbiting a star that no longer existed. That's how strong and yet fragile light's link with time truly is. You can think of the universe as a great theatre, and light is the only courier allowed to deliver news between its distant stages. But since it can never go faster, the news it brings is always old. When you look up at a star, you are reading a headline from years, centuries, or even eons ago. Let's make that more vivid. Light from Proxima Centauri, our nearest stellar neighbor, takes over 4 years to reach us. That means if a civilization were living there with a telescope pointed at Earth, they'd be watching the events of 4 years ago, not the present. They'd see birthdays, storms, and sunsets already gone by. If they tried to send us a reply, we'd get it 8 years later. In the cosmic scale, communication is a conversation with ghosts. This delay defines everything we know about astronomy. Telescopes don't just collect images, they collect memories. When the James Webb Space Telescope peers deep into the void, it's not looking at what is, it's seeing what was. The faintest galaxies it captures might have sent their light more than 13 billion years ago, when the universe was still in its childhood, just beginning to form stars. It's a strange kind of paradox. The faster you move toward the edge of the universe, the further back in time you go. Space and time are tangled together, inseparable. That's what Einstein realized when he described space-time, a flexible, dynamic fabric that stretches, bends, and carries every particle and photon along with it. Light doesn't just move through space, it shapes it. Close your eyes for a moment. Picture a beam of light leaving a distant star. It slips past planets, nebulae, black holes, through the cold, silent dark, never aging, never slowing. For billions of years it travels unbothered until it reaches the tiny window of your vision. You catch it in a blink, and in that instant, a billion-year-old story ends inside your eyes. But here's the fascinating thing. Even though light travels incredibly fast, it's finite. And that finiteness lets us build cosmic clocks. By measuring how much the wavelength of light has stretched, we can estimate how far and how long it's traveled. The redder the light, the longer it's been on the road. Astronomers call this redshift, a fingerprint of time itself. Think about that. Color as a measure of age. The deeper the red, the older the memory. When you see the soft crimson of a dying star, you're witnessing something ancient, something that may already be gone. Its story lingers as a glow in the night. And so the speed of light is not just a number, it's the rhythm of the universe. It decides what we can see, what we can never see, and what we must simply imagine. There's a strange piece in that, isn't there? To know that we're always looking at yesterday, yet we still find beauty in it. Maybe that's why starlight feels nostalgic. It's literally the past, shining gently into the present as you lie there, maybe listening to your own breathing syncing with the calm pulse of the night. Imagine all those photons still on their journey. Rivers of light flowing through the dark, heading somewhere, maybe toward other eyes in another world. The universe is full of witnesses, each separated by time but joined by the same quiet wonder. The light from our own sun is a perfect reminder of how we live inside a constant delay, a soft echo of what once was. It takes 8 minutes and 20 seconds for sunlight to reach Earth. That means the warmth touching your skin, the glow through your window, even the sunrise you admire in silence each morning. All of it began more than 8 minutes ago. Every dawn is a replay. It's easy to forget this. The sun feels so immediate, so alive. Yet if something miraculous or catastrophic were to happen there this very second, we wouldn't know right away. For more than 8 minutes, our world would keep orbiting, glowing, breathing, unaware. In that fragile span of time, billions of photons are still in flight, completing their journey across 150 million kilometers of space. When you think about it, that delay gives life its rhythm. Plants, oceans, weather, and our very sense of day and night are choreographed by light that left the sun minutes earlier. Every leaf that unfurls, every shadow that moves is responding to the past, not the present. It's humbling, isn't it? The most immediate thing in your life, sunlight, is already history, and yet it sustains everything. Now imagine yourself drifting upward, leaving Earth behind, seeing that golden star from space. It pulses and ripples with energy, a furnace of nuclear fusion converting hydrogen into helium, the same process that powers every star you'll ever see. The light it releases bursts outward in every direction, scattering across the solar system like the breath of creation itself. That glow touches Mars after 13 minutes, Neptune after 4 hours, and Pluto after 5 hours. Beyond that, sunlight becomes a whisper. At the edge of the solar system, it's a faint sigh of gold, barely strong enough to illuminate the cold surface of comets drifting in the dark. Even so, that light keeps traveling. Long after it leaves our planetary neighborhood, it continues on, fading, thinning, until it becomes just one more particle of the Milky Way's endless haze. Somewhere, millions of years from now, those very photons might reach another world, another watcher, who will see our sun as it once was, small, distant, and long gone. When scientists first measured this speed of light delay in the 17th century, it changed everything. The astronomer Ola Roma noticed that the eclipses of Jupiter's moon Io didn't happen exactly when expected. Sometimes they were late by minutes. He realized the difference came from the changing distance between Earth and Jupiter as both planets moved around the sun. When Earth was farther away, the light took longer to reach us. From this simple observation, humanity glimpsed something extraordinary. Light had a speed, finite, measurable, and universal. That discovery was like pulling a veil off the cosmos. It told us that the sky we see isn't happening now. It's a layered mural of moments scattered through time. Each point of light tells a story from a different age. Some seconds old, some millennia, some almost as ancient as time itself. You can almost feel it when you watch a sunset. The last sliver of the sun dips below the horizon, but the light you're seeing has already left. For a moment you're witnessing a ghost of warmth, a farewell from the past. And yet it feels real, immediate, alive. Maybe that's the quiet magic of the universe, the past and present always overlapping, always speaking softly to each other through light. Close your eyes and picture yourself floating just beyond Earth's atmosphere. The sun's rays scatter against the curve of the planet, painting the clouds in gold and violet. That color, that glow, is the universe's way of saying, you are part of a much older story. So the next time you stand in daylight, remember, it's not just light you're feeling, it's history. A message that began before your heartbeat, before your morning coffee, before you even opened your eyes. 8 minutes of light. And yet, in that delay, the whole miracle of life unfolds. Now let's drift a little farther from home, beyond the reach of sunlight's quick embrace, to our nearest stellar neighbors. When you look toward the constellation of Centaurus, you're seeing a small cluster of stars bound together. Alpha Centauri A, Alpha Centauri B, and the tiny red dwarf called Proxima Centauri. They sparkle faintly, a mere glint to the naked eye, but they hold a profound truth. Every shimmer from them began its journey more than 4 years ago. That means if someone was standing on a planet orbiting Proxima Centauri right now, and looked back toward Earth with a powerful telescope, they wouldn't see you as you are tonight. They'd see Earth 4 years in the past. The sunlight reflecting off oceans, the movements of clouds, even the flicker of our cities would all be a replay. In a sense, every civilization, every world, is trapped in its own bubble of now, surrounded by countless layers of someone else's yesterday. Light creates a beautiful illusion of immediacy, but in truth, we're always late to the party. The Alpha Centauri system could have changed entirely since the light we see left it. Planets could have shifted, stars could have flared. We wouldn't know yet. The universe keeps its secrets behind a delay no one can escape. Astronomers call this the light travel time, and it's one of the most poetic phrases in science. It means that to see is to remember. The Alpha Centauri light entering your eyes tonight began traveling before the last US presidential election, before a baby born then could even start school. And when you watch it flicker, you're bridging that gap with nothing more than your gaze. This isn't just about curiosity, it's how we map the universe. Scientists use the finite speed of light as a ruler. When they say a star is 4 light years away, they're saying its light took 4 years to arrive. That distance is enormous, to nearly 40 trillion kilometers. But to the cosmos, it's next door. Farther out, the scale becomes dizzying. The light of Betelgeuse, the red supergiant marking Orion's shoulder, takes about 642 years to reach us. When you stare at that glowing ember in the sky, you're seeing the medieval world reflected in its light. Castles, torches, and silent nights before telescopes even existed. Some scientists think Betelgeuse might already have exploded into a supernova, a brilliant flash that would outshine every other star for weeks. But if it did, that light hasn't reached us yet. We might wake one night to see it, or maybe not for centuries. That's what makes the night sky so haunting. It's both real and outdated, a living photograph that can never be updated. If you listen carefully to the silence of the universe, it almost feels like it's whispering. You're seeing me as I was, not as I am. Even our galaxy's glow carries this echo. The nearest clusters shimmer with light thousands of years old. The faint mist of the Andromeda galaxy? You're watching photons that left there about 2.5 million years ago, when early humans were first learning to use tools. Those waves of light crossed the vast void between galaxies to reach your eyes, carrying not just information, but an unbroken thread of existence. And somewhere in Andromeda, if intelligent life exists, their telescopes might now be catching the first flickers of our ancestors' campfires on Earth. A mutual glance across time, 2 civilizations unknowingly watching each other's ancient history. There's something deeply comforting about that idea. We often feel small, insignificant, fleeting. But in the eyes of the cosmos, we are part of a long-running broadcast, one where every ray of light from every world carries a story. So next time you look up and see the nearest stars glimmering in the dark, remember they're not shining for the present moment. They're sending postcards from the past, written in light, addressed to whoever is patient enough to wait. In the great cosmic theatre, we're all both audience and actor, each watching the other's performance, separated by oceans of time. Now, let your mind drift even deeper into space, far beyond the familiar pinpricks of nearby stars. Out there, beyond the reach of our naked eyes, lies an ocean of galaxies. They shimmer faintly in the black, delicate spirals, glowing ellipses, and irregular clouds of starlight, each one a vast city of suns. But here's the breathtaking part. When you look at them, you are not seeing what they look like now. You are seeing them as they were millions or even billions of years ago. Every distant galaxy is a frozen photograph from a different era. The faint smudge of light that your telescope catches tonight may have started its journey before Earth even existed. Imagine that, long before our sun was born, before the oceans formed, before life itself, a photon left a distant galaxy and began its silent flight through time. Only now, billions of years later, does it finally arrive to whisper its story. If you've ever seen an image from James Webb Space Telescope, JWST, those dazzling cosmic tapestries filled with tiny specks of light, you've seen this time travel with your own eyes. Many of those golden red dots in its deep field images are entire galaxies whose light has been traveling for over 13 billion years. That means we're seeing them as they appeared just a few 100 million years after the Big Bang, when the first stars were being born, when the universe was still dim and turbulent, filled with glowing hydrogen clouds. It's almost impossible to comprehend, isn't it? You're looking at ancient light that began its journey before there were planets, trees, or people to witness it. And yet here it is, captured by glass, mirrors, and human curiosity. These galaxies are like cosmic fossils. By studying their light, astronomers learn not only what the universe once looked like, but how it changed, how gravity sculpted stars into spirals, how collisions forged new worlds, and how everything we know came to be. Every photon carries a clue, every faint glow a timestamp written in color and brightness. Light, after all, doesn't just illuminate, it preserves. It holds the memory of everything that ever burned, collided, or changed in the vastness of space. And because it takes time to move, it gives us something precious, the ability to look backward. Think about this. When you gaze at the Andromeda Galaxy, the nearest large neighbor to our Milky Way, you're seeing light that left it about 2.5 million years ago. In human terms, that's before our species existed, when our ancestors were shaping crude tools from stone and learning to survive the African plains. That light has crossed a gulf of emptiness so vast that even light, the universe's speed champion, took millions of years to bridge it. And as you look at Andromeda tonight, remember, it's moving toward us. In about 4 billion years, it will collide with our Milky Way, two galaxies merging in a slow cosmic dance, their stars weaving together, their black holes spiraling into one. That event will light up the skies of distant descendants, and if anyone is still here to see it. But the irony is, even when they watch it unfold, they'll still be seeing parts of it as they were millions of years before. That's how deep this illusion goes. In the universe, nothing is ever live. Even the most violent events, supernovae, gamma bursts, the birth of stars, are ancient by the time we see them. Space is a time machine, and we're all passengers looking out the window. You might be wondering, if we can see that far into the past, can we ever see the present universe? The answer is quietly poetic, no. The present is always hidden from us, always slightly out of reach. Everything you see, even the reflection in a mirror, is delayed by a whisper of time. The universe never lets you see now. It only lets you remember. And maybe that's why starlight feels so different from any other light. Candlelight warms you, moonlight comforts you, but starlight teaches you humility. It's a reminder that everything, including us, is built from ancient stories still arriving from the dark. So the next time you look up at that pale mist of galaxies, let it sink in. You're looking not at what's there, but at what was. A museum of light scattered across the void, each beam older than imagination itself. In astronomy, there's a beautiful concept called look-back time. It's one of those phrases that sounds poetic, but is, in fact, perfectly scientific. It means that when we observe something in space, we're seeing it not as it is now, but as it was when the light first began its journey to us. Every image we capture, every galaxy, every star, every nebula is a look backward through the layers of cosmic history. The farther we look, the older the universe becomes. Our telescopes are not just instruments of sight, they're time machines. Each lens, mirror, and sensor is tuned to catch whispers of light that have been traveling for billions of years. What they reveal is nothing less than the autobiography of the cosmos. Imagine standing on the edge of a vast canyon, shouting and waiting for your echo to return. The farther away the wall, the longer the delay before the sound comes back. Space works the same way, except its walls are galaxies and its echoes are made of light. When astronomers aim telescopes like the Hubble or the James Webb Space Telescope, JWST, into the deepest, darkest patches of sky, they're essentially listening for those echoes. What comes back are messages from the past, some so old they date to the first billion years of cosmic existence. When JWST took its first deep-field image, the world paused. Within that single frame, no bigger than a grain of sand held at arm's length, were thousands of galaxies. Some of their light had traveled for over 13.5 billion years to reach the telescope's golden mirrors. That means JWST was seeing those galaxies as they appeared just a few 100 million years after the Big Bang, long before the Milky Way even existed. Each galaxy in that image is a frozen moment, a memory of what the universe once looked like. Some are blue and young, bursting with the first generations of stars. Others are red and faint, ancient even then, their light stretched by the expansion of space itself. The deeper we look, the redder the light becomes. It's called cosmological redshift, and it's one of the universe's most beautiful fingerprints. You could think of it like this. As the universe expands, the fabric of space stretches the light traveling through it, making it longer in wavelength and redder in color. The more it's stretched, the older it is. By measuring that stretch, scientists can tell how far back in time we're peering, like counting tree rings of light. But here's what makes it even more profound. When you see those faint galaxies glowing in JWST's images, you're not just seeing what they looked like billions of years ago, you're seeing the early universe itself, the time when the first atoms gathered, the first stars ignited, and the first galaxies formed out of the cosmic fog, and those galaxies are still out there, evolving, colliding, aging, but we'll never see them as they are now. They're forever frozen in that ancient light. The JWST doesn't capture the present, it reveals the beginning. Light is patient. It doesn't care how long it travels, only that it keeps going. That's why it can serve as both messenger and historian. Every beam of light carries a record, not just of time, but of conditions, elements, and motion. Astronomers can decode those records like archaeologists studying fossils, using spectra instead of bones. From a faint red streak, they can tell what gases a galaxy held, how fast it was moving, and even how old its stars were when that light began its voyage. It's mind-bending to realize that the universe gives us no direct view of the present. All we have is a tapestry woven entirely from the past, stitched together by photons that began their journey across unimaginable gulfs of darkness. And yet, in this strange limitation lies beauty. Because to look at the universe is to see everything that has ever been. It's like holding a cosmic photo album where every image is still arriving, where time itself becomes visible. So when you see those deep field images, the spirals, the glowing filaments, the faint red smudges that seem almost unreal, remember this: each one is a glimpse into yesterday's eternity. You're looking at the baby photos of creation itself, and somewhere, in a distant future we'll never see, another being may gaze into the void and catch the faint, ancient light from our own Milky Way. And they'll call it look-back time, too. Now imagine for a moment that you could drift alongside the James Webb Space Telescope, floating silently in the cold void 1 million miles from Earth. Around you, there's no sound, only the steady hum of instruments gathering light. JWST stares deep into the abyss, and what it sees isn't the modern universe at all. It's the baby universe still blinking awake after the Big Bang. Through its golden mirrors, Webb captures galaxies so faint and redshifted that their light has been stretched by the expansion of space itself. These are the first galaxies. Tiny, irregular clumps of stars born when the cosmos was less than 500 million years old. Back then, there were no grand spirals, no majestic clusters, just islands of newborn light scattered in the darkness. To look at them is to witness creation still in progress. That's the power of seeing the baby universe. JWST isn't showing us the distant past as an abstract idea. It's revealing it as an image. Real, visible, shimmering before our eyes. Every pixel in those breathtaking photographs is a message from the dawn of time. The light you see left its home when the first stars were fusing hydrogen for the very first time. The universe, in its infancy, was a very different place. It was smaller, denser, and darker. For hundreds of millions of years after the Big Bang, light couldn't travel freely. It was trapped in a fog of charged particles. Astronomers call this period the cosmic dark ages. Only when the first stars ignited did the universe begin to clear, letting light finally escape and spread. What JWST sees are the moments just after that, when the fog lifted and the first cosmic dawn began. If you close your eyes now, you might picture it, space filled not with glittering constellations, but with vast, glowing clouds of hydrogen slowly collapsing under gravity's pull. Within those clouds, the first stars were born, colossal and short-lived, burning hot and blue. They blazed briefly, lived fast, and died in explosions that seeded the cosmos with the heavier elements that would one day form planets, oceans, and life. So when JWST peers into that deep red light, it's not just looking backward, it's looking at our own origins. Those ancient suns created the carbon in our breath, the calcium in our bones, the iron in our blood. Every element inside you was once part of a star that burned in the early universe. And yet, what you're seeing in those images is only a fraction of what was there. Much of the early universe remains hidden. Its light stretched beyond the visible spectrum, deep into the infrared. That's why Webb's instruments are tuned precisely to those wavelengths. They can see what Hubble never could. Galaxies so ancient their visible light has been stretched into invisible heat. Each observation Webb makes is a whisper from the beginning. Some of its data come from light that left its source 13.4 billion years ago. Think about that. Before Earth, before the Sun, before even the Milky Way had formed, that light was already on its way here. When scientists process the images, they aren't just seeing dots and colors, they're reading history. The shapes of those galaxies, the brightness of their cores, the patterns of their spectra, all tell a story about how structure formed in a universe, just learning to organize itself. And yet, beyond the data and the measurements, there's a quiet poetry in all this. The telescope isn't just showing us something far away, it's showing us something deeply intimate. The atoms that make up your eyes, your heart, and your thoughts were born in that same ancient fire. When you look at those distant galaxies, you're literally seeing your own beginnings. The light that traveled 13 billion years to reach us has finally arrived, and it ends its journey in you. You are its destination, its witness. So tonight, when you see an image of those tiny crimson smudges captured by JWST, remember, that's not just the universe's past. It's your past too. The very matter that would one day think, dream, and build telescopes was once glowing in those newborn galaxies, unaware that one day it would look back and call itself human. Now let's flip the perspective, Dylan. Not from Earth looking out, but from somewhere else far away, looking back at us. Imagine a civilization living in a galaxy 100 million light years away. Maybe they too have curious eyes and great telescopes pointed toward our little spiral arm of the Milky Way. What would they see? They wouldn't see you or me. They wouldn't see cities, satellites, or even dinosaurs. They'd be watching Earth as it was 100 million years ago, when giant reptiles ruled the land and the first flowers were just beginning to bloom. To them, our world would be a place of thunderous footsteps and tropical swamps, not one of quiet blue oceans and cities of light. That's the paradox of light. It always reveals, yet never reveals now. Every vantage point in the universe comes with a time delay. Our present is invisible to anyone far away, and their present is invisible to us. We are all trapped in our own slices of time, connected by the long, patient threads of light. If you were somehow able to step outside the universe and watch it all unfold at once, past, present, and future together, it would look like a shimmering sculpture of light, frozen in 4 dimensions. Every photon, every reflection, every moment of brightness would be preserved, woven together into one luminous whole. But from where we stand within time, all we ever see are the layers peeling away behind us, history glowing faintly in the dark. Think about it this way. If some alien astronomers, 1 billion light years away, were to look toward our sun right now, they wouldn't see humans. They wouldn't see Earth at all. They'd be looking back in time to an age before our planet even existed, before our star had gathered the dust that would one day form us. They'd see a blank patch of space where the sun would eventually be. And here's something even stranger. There are likely civilizations whose light hasn't reached us yet. If intelligent life exists elsewhere, perhaps orbiting a distant red star, their messages of light are still on the road, still traveling through the void. We won't see them for thousands or millions of years, long after we ourselves are gone. So in a cosmic sense, the universe is a conversation with enormous pauses. Every star, every galaxy, every being sends its words, its photons, out into eternity, never knowing when or if they'll be received. It's a vast exchange of memories, written in light and delayed by distance. But there's something quietly comforting about that too. It means that nothing truly disappears. Even after a star dies, its light continues to travel. Even after a civilization fades, its glow remains, still on its way to somewhere. The night sky is full of ghosts, yes, but also full of persistence. Now bring that thought closer to home. When you look at the moon, you're seeing it 1.3 seconds in the past. When you look at the sun, 8 minutes. Mars, anywhere from 4 to 20 minutes, depending on where it is in its orbit. And when you look at the nearest galaxies, you're seeing them as they were millions of years ago. That means the further your gaze extends, the more ancient the light becomes, until the present itself fades completely. If we had the technology to stand on a world orbiting a distant star and look back at Earth, we could literally watch history. We could see the dinosaurs rise and fall, the continents shift, the first sparks of human civilization. The light of our entire story, every sunrise, every fire, every city, is streaming outward right now into space, into forever. There's a quiet, almost sacred symmetry in that. As we gaze out at other worlds' pasts, so too does our own world become someone else's ancient light. Earth is already a fossilized photograph drifting across the cosmos, a faint blue glow from a distant yesterday. So maybe when you look at the night sky, you're not just observing, you're participating. You're part of that great exchange, one world watching another, all of them illuminated by memories. Every beam of light is proof that the past is never truly gone. It's still traveling, still reaching out, still telling its story, waiting for someone, somewhere, to look up and listen. Let's wander deeper into that quiet night sky. Dylan to past the bright constellations and familiar stars, into the realm of the dead. Out there, in the darkness between galaxies, shines light from stars that no longer exist. What you see as beauty might, in truth, be the final echoes of something that burned out long ago. Every star has a lifespan. Some live for billions of years, burning gently and slowly, like our sun. Others live fast and die young, massive blue giants that shine with furious brightness before collapsing in colossal explosions known as supernovae. But even after they die, their light keeps going, racing outward through the void, crossing unimaginable distances and timescales. When you look up tonight, it's almost certain that some of the stars twinkling above you have already gone dark. They've ended their lives, scattered their ashes into space, and yet they still shine in your eyes. You're seeing them not as they are, but as they were. Their photons are ghosts, still traveling, still carrying the image of what once was. That's not just poetry, it's physics. Light doesn't need permission to keep going. Once released, it moves forever, unaffected by time, until something, a planet, a telescope, an eye, finally stops it. That's why the night sky is full of shadows of dead stars. Their bodies are gone, but their light lives on. Proof that memory can outlast matter. Imagine watching a supernova, the moment when a dying star tears itself apart, releasing more energy in seconds than our sun will emit in its entire lifetime. The light from that explosion races outward in all directions. For thousands or millions of years, it travels across the galaxy until one night it reaches us. We see the flash, bright enough to cast shadows on Earth, and we call it a new star. But it's not new at all. It's the funeral fire of a distant sun, arriving long after the death it commemorates. One of the most famous examples is supernova 1987A. In the Large Magellanic Cloud, its light reached us in 1987, but the explosion itself happened about 168,000 years earlier. The star had died when early humans were still painting caves and discovering fire, and yet we saw it only recently. For an instant, the past broke through, brilliant and undeniable. The same is true for many of the constellations we know. The belt of Orion, the curve of the Big Dipper, they're composed of stars scattered across vast distances and ages. Some are alive, some are long gone, but their lights reach us together, blending into a single pattern. What we see as a constellation is really an illusion, a time collage, assembled from different centuries, even millennia. It's haunting when you think about it. Our night sky is a cemetery that glows, but it's not a sad one. It's full of persistence and grace, the quiet endurance of light refusing to fade. And sometimes that light tells us more than we expect. When scientists analyze the faint spectra of starlight, they can tell what elements the star contained: hydrogen, helium, carbon, iron. From those patterns, they can reconstruct its story, its temperature, even the kind of death it met. In that sense, starlight is a message in a bottle, drifting across eternity. Now, here's the poetic twist: the calcium in your bones, the iron in your blood, the oxygen in your lungs, all of it came from such dead stars. You are quite literally the ashes of the past. The light you see at night is family light, ancestral light, so when you gaze at the stars, you're not just looking at them. You're looking at where you came from. You're seeing the long lineage of existence, still shining even after death. If you let your mind quiet down enough, you can almost hear them. Not words, but the rhythm of persistence, the steady heartbeat of something that once lived, still sending light through the dark. Every photon that reaches you tonight is an invitation. Remember that everything beautiful is temporary, but its light, its impact, can travel farther than anyone imagines. And so, the next time you lie beneath the stars, realize this simple truth: you are surrounded by the past, illuminated by the remains of long-gone suns. Their stories end, but their light writes ours. Look up again, Dylan. Take in the whole sky, the silver dust of the Milky Way stretching from one horizon to the other. Every point of light you see is both a life and a memory. The stars shimmer, not just because of the atmosphere, but because their light trembles through time. Some are alive, some are gone, and together they create what I like to call a sky full of ghosts. It sounds eerie, but it's not meant to frighten. It's meant to awe. Because every glimmer, every faint sparkle overhead is proof that light doesn't surrender easily. It carries on through billions of years, refusing to let stories end. You, me, everyone who has ever lived, we're all bathed in that ancient radiance every night. The ghosts of stars are our quiet companions. You could call the night sky the greatest memorial in existence. Not one built of stone or words, but of light. The afterglow of everything that ever was. Somewhere up there, photons released by dead suns still wander. They touch our planet, our oceans, our eyes. They light up mountaintops and city windows. And though the stars themselves may be gone, the universe refuses to let their brightness vanish entirely. If you were to step into the vacuum of space, the darkness between stars would still shimmer faintly with what scientists call the cosmic background light, the faint radiation from everything that has ever shone. It's a residue of existence itself, filling every cubic centimeter of the cosmos with the memory of creation. The universe doesn't forget. It glows with its own past. And that glow isn't just ancient, it's layered. The cosmic microwave background, the faint radiation left from the Big Bang, is like the oldest ghost of all. Light released when the universe was only 380,000 years old. To telescopes, it appears as a whisper of warmth, just a few degrees above absolute zero. But to physicists, it's the first photograph of reality. The ultimate family portrait. So when you gaze at the stars, you're seeing ghosts on every scale, from the flicker of a long-dead supernova to the soft echo of the birth of time itself. It's strange, isn't it? We spend so much of our lives fearing endings, yet the universe is full of them, and it wears them beautifully. Each light is both an ending and a beginning, a bridge between what was and what will be. You could think of it as a cosmic graveyard that never feels morbid, because in space death is not destruction, it's transformation. The ashes of one generation of stars become the material for the next. When a supernova scatters its remains, those fragments drift through the galaxy and condense into new suns, new planets, new possibilities. Even ghosts create life. And so when we look up, we are seeing more than beauty. We're witnessing renewal. The Milky Way's faint white band isn't a static decoration. It's the combined light of hundreds of billions of stars, some shining, some long, gone, some not yet born. It's a slow, eternal heartbeat written in photons. The galaxy is alive in ways we can't yet fully grasp, not in years or decades, but in eons. Sometimes I like to imagine all the people throughout history who've looked at this same sky. From ancient sailors charting constellations, to astronomers sketching nebulae through small glass lenses, to a child lying on the grass tonight, the same light touches us all. The ghosts that reach you now once brushed against the eyes of every dreamer who ever wondered what lies beyond. There's comfort in that continuity. Maybe we don't disappear completely either. Maybe the traces of our lives, our words, our warmth, the photons bouncing off our faces, also wander off into the universe, joining that endless glow. 1 billion years from now, our light might drift into another world's sky, and someone there might feel the same quiet awe we do tonight. So yes, the night is filled with ghosts, but they're friendly ones, luminous memories, silent witnesses. They remind us that nothing bright ever truly dies. The universe, vast and patient, keeps every light, every story. It turns death into memory, memory into beauty, and beauty into the soft, eternal shimmer above our heads. Next time you look up, don't think of stars as distant or unreachable. Think of them as echoes, each one whispering, "I was here, I existed, and I still shine." Now that your eyes have adjusted to the dark, imagine holding a telescope, not as a tool of power, but as a portal. With each twist of its focus, you aren't just sharpening a view, you're lengthening time. Telescopes don't merely magnify distance, they stretch time backward, allowing us to witness what no living creature could ever see firsthand. From Galileo's first refractor in 1609 to the gleaming mirrors of JWST today, every telescope has been a time machine. Each one reaches a little further, peeling back another layer of the universe's story. When Galileo turned his telescope toward Jupiter and saw its moons circling, he wasn't just observing, he was rewinding time by minutes. When Edwin Hubble photographed distant galaxies, he was looking back millions of years. And when JWST stares into the deep infrared, it drifts billions of years into the past. It's as if each improvement in optics has been a deeper breath of history, a way to pull more of the ancient light into the present. But how does it work? Light is faint, fragile. The farther it travels, the weaker it becomes. That's why telescopes are built with enormous mirrors to collect more light, to hold on to the oldest photons before they vanish into the noise of space. Every second that a telescope keeps its gaze fixed on one point of the sky, it gathers more of those faint whispers. Hours become days and the picture slowly brightens. What you see in the final image is not a snapshot. It's a long exposure of time itself. Think about that. What JWST reveals in one picture is the sum of thousands of hours of waiting. Light that left ancient galaxies long before our solar system existed finally meets a mirror made by human hands. It's an encounter between the newborn and the old, the beginning and the curious now. When you look at those golden images, the filaments of galaxies, the glowing star nurseries, the dark gaps of cosmic dust, you're looking at the product of patience. The telescope doesn't rush light, it simply listens longer than we can. There's something deeply human in that. We live our lives in moments, in flashes of presence. But telescopes teach us endurance. They remind us that truth reveals itself slowly, that the universe rewards stillness and focus. And they do more than show us what was. They measure time. By capturing the same patch of sky again and again, astronomers can watch stars explode, galaxies merge, and even the faint shift of distant supernovae fading away. We can literally see change frozen across epochs, a kind of cosmic stop motion. The Hubble Ultra Deep Field, for example, is a miracle of patience. Astronomers aimed Hubble at an empty patch of space for over 11 days of continuous exposure. The result? Over 10,000 galaxies, each one a different chapter of cosmic time. What looked empty was, in truth, overflowing. And JWST goes even further. It doesn't just collect light, it collects the oldest possible light. Its instruments can see wavelengths invisible to the human eye, stretched by the expansion of the universe into the infrared. That's why it's sometimes said that JWST doesn't look through space, it looks through time itself. Even amateur astronomers peering through backyard telescopes take part in this quiet time travel. Every time you observe Saturn's rings or a nebula glowing faintly in Orion, you're touching history. You're intercepting photons that have traveled for years, centuries, or millennia. And for a fleeting second, they belong to you. Sometimes I think about that when I'm under a clear sky. How every telescope ever built is really an act of curiosity turned into devotion. Humans building instruments not to conquer space, but to remember it, to hold light long enough to understand it, because that's what telescopes really do. They stretch the present to make room for the past. They allow us to stand in 2 times at once, now and billions of years ago. So the next time you see a telescope pointed skyward, imagine it not as a machine of glass and steel, but as a bridge. One end anchored in your moment, the other reaching deep into a time before life, before stars, before anything known. And as that beam of ancient light settles into the mirror, realize something profound. The universe has been waiting all this time to be seen. Picture the universe, Dylan, not as a flat canvas, but as a vast layer cake of time, each slice a different age of existence, stacked atop the next. The deeper you look into space, the deeper you cut into that cake. And at the bottom, glowing faintly through billions of years of cosmic dust, lies the beginning. Astronomers sometimes describe this as the time layers of space, a beautiful and haunting truth. The night sky isn't a single moment spread out before you, it's a timeline. The closer stars near us show what the universe looked like in recent centuries or millennia. Beyond them, the faint, reddish smudges of distant galaxies take you millions, even billions, of years back. And if you could somehow see to the very edge of the visible cosmos, you'd be looking 13.8 billion years into the past, right to the dawn of light itself. Everything we know is nested inside those layers, each one more ancient than the last. You could think of it like rings in a tree, except instead of wood, the universe's rings are made of light. Imagine floating in a bubble with Earth at its center. Around you, each layer of that bubble represents another era of time. The moon, 1 second ago. The sun, 8 minutes. The nearest stars, years. The edge of the Milky Way, tens of thousands of years. The farthest galaxies, billions. The farther your gaze extends, the older the layer. What you're really seeing is the archaeology of light, and the farther we dig, the stranger it becomes. At first, the layers are familiar: galaxies, stars, planets. But deeper down, things start to look primitive. The galaxies are smaller, more chaotic. Their stars are hotter and younger. Keep going, and the light begins to shift toward red, faint and ancient, until it blurs into the cosmic background radiation, the faint afterglow of the Big Bang. Beyond that lies darkness, not because there's nothing there, but because light itself hadn't yet begun its journey. It's hard to grasp that, isn't it? The idea that you can look across billions of light years and literally see time changing, moment by moment, layer by layer. That's what makes astronomy so extraordinary. It lets us see history. Every direction you look is a different when. In the Cosmic Museum, there are no separate exhibits for then and now. Everything exists simultaneously, superimposed in the sky. A star dying in one corner, a galaxy being born in another, all visible at once, though separated by unimaginable eras. To the universe, time is not a line, but a landscape, and you, right now, are standing on one of its newest hills, looking back over the valleys that came before. When the Hubble Deep Field was first released, people were stunned not just by the number of galaxies it contained, but by their variety, some mature and graceful, others chaotic and unfinished. It was like seeing snapshots of different centuries laid side by side. The photograph wasn't a single moment, it was an atlas of time. WST has taken that even further, showing us the earliest known galaxies, small, lumpy things like cosmic embryos. In those ancient shapes, scientists can trace how everything evolved, how clumps of matter merged, how the first stars formed, how the universe grew structure from chaos. Every one of those discoveries adds another layer to our understanding, not just of space, but of our own origin. Because those same processes that built galaxies also built the atoms inside you. You are, in a literal sense, the surface of one of the newest layers of time, composed of matter from the deepest ones. If you could peel back those layers like pages of a book, you'd see your own story written in reverse. The sun forming from dust, the dust forming from old supernovae, the stars themselves igniting in clouds born from the Big Bang's residue. You are the echo of every chapter that came before, and the most astonishing part, the light from all those layers is still arriving. Even as you sit here now, photons that left their galaxies billions of years ago are hitting your eyes. You are continuously being touched by the past, bathed in it, surrounded by it. So when you look at the sky tonight, don't think of it as distant, think of it as deep. A cathedral of light built layer upon layer, each one glowing softly with the memory of what once was. The stars are not far away, and they are ancient. The night is not empty, it is full of history. And you, small and luminous in your own way, are one more layer in the story, one more flicker of light added to the tapestry of time. If you could somehow step outside the universe and look back at it from beyond, not just in space but in time, you would see that light, space, and time are all threads of one vast tapestry. That's what Albert Einstein realized when he rewrote our understanding of reality. The cosmos isn't a stage where light moves through time. Light is time woven into space itself. He called it space-time, a four-dimensional fabric that curves, bends, and stretches. To Einstein, there was no absolute now. What you call the present depends entirely on where you are and how you move. A moment for you on Earth might not exist yet for someone near a distant star. And the only thing that ties those two perspectives together is light. Light is the messenger that keeps the universe connected. It's the courier of truth, the signal that defines what is visible, knowable, and real. But it's also the universe's ultimate limit. Nothing can go faster, not even information itself. The speed of light isn't just a number. It's the cosmic speed limit, the heartbeat of reality. Everything, time, gravity, even causality, depends on it. Einstein showed us that when something moves closer to the speed of light, time itself slows down. Clocks tick slower, distances shrink, mass increases. To a photon, a particle of light, time doesn't pass at all. From its perspective, the moment it leaves a star and the moment it hits your eye are the same instant. Light lives outside of time. That's one of the most beautiful ideas in all of science. The light you see tonight has traveled for millions or billions of years. Yet for the photons themselves, no time has passed. They began their journey in eternity and arrived here still untouched by age. You're not just seeing into the past. You're touching something timeless, and it gets even more astonishing. Gravity, that familiar force that keeps your feet on the ground, isn't really a force at all. It's the curvature of space-time caused by mass and energy. A planet bends the fabric of reality around it, and other objects move along those curves. Even light, though massless, follows those bends. That's why massive objects like stars or black holes can bend light, a phenomenon called gravitational lensing. When astronomers look at distant galaxies through these cosmic lenses, they often see distorted arcs and mirrored shapes. What they're really seeing is space-time itself, twisted by gravity, bending the path of light like glass bending a beam. Sometimes, one distant galaxy can appear multiple times, reflected around a cluster of galaxies closer to us. A cosmic hall of mirrors, created by the geometry of the universe. It's hard not to feel small before that realization. Every photon you catch, from a sunset, a candle, or a galaxy, has traveled through this invisible web of curvature, sliding along valleys carved into space-time by stars, planets, and dark matter. You're not just an observer of the universe, you're part of the geometry that gives it shape. And this geometry isn't static. It moves, expands, warps. The space between galaxies stretches with time itself, carrying them away from one another. The further apart they are, the faster they recede. Not because they're flying through space, but because space itself is expanding. The light we see from them is stretched along the way, its wavelength growing longer, redder, the universe's way of aging its own memories. Einstein's theory predicted this kind of dynamic universe, one that changes, flows, and evolves. But even he was reluctant to accept it. It took the work of others, Hubble, Lemaitre, Friedman, to prove that the cosmos was expanding and that everything we see today once began from a single, hot, dense point, and so the fabric of light and time continues to unfold. Each photon, each wave, is like a wrinkle in that cosmic sheet, carrying news from the past to the present, linking us to places and moments we'll never visit. Sometimes, late at night, when the air is still and the stars seem impossibly sharp, it helps to remember the light entering your eyes doesn't just cross space. It slides down invisible curves, dances through time, and whispers stories written in the language of relativity. You are, right now, part of that same web. Gravity bends the space beneath your feet. Time flows differently for you than for the stars above. Light threads through it all, binding everything, from the smallest atom to the farthest galaxy, into one continuous whole. So when you gaze upward, remember that you're not outside the universe looking in. You're inside the fabric itself, woven from the same threads of light and time that you're trying to understand. You are both observer and pattern, a brief shimmer in the cosmic tapestry that never stops unfolding. For all that light has shown us, Dylan, there's one truth it cannot change, a horizon we can never cross. Because even light, fast as it is, hasn't had enough time to reach us from everywhere. There are parts of the universe we will never see, not because they don't exist, but because their light is still on its way and may never arrive. Astronomers call this invisible boundary the cosmic light horizon, or sometimes the observable universe's edge. It marks the limit of what light has had time to travel since the universe began about 13.8 billion years ago. But because space itself has been expanding while that light was in motion, the true distance to that horizon is closer to 46 billion light-years in every direction. Beyond it lies more universe, perhaps much more, that we can never observe. It's not hidden behind dust or darkness, it's hidden behind time itself. The light from those regions hasn't had enough cosmic history to reach us yet, and as space continues to expand, it likely never will. Those places are forever beyond our reach. Think about that. An infinity of stars, galaxies, and possibilities sealed away by the physics of distance and time. Even if we traveled at light speed forever, we'd never cross that threshold. The universe doesn't just stretch outward. It stretches faster than light itself. It's humbling to realize that what we see, this glorious dome of galaxies, might be only a small part of something unimaginably vast. We live inside a cosmic island of light, surrounded by an ocean of darkness we can never explore. Beyond that ocean, space keeps growing, birthing galaxies whose light will never meet ours. It's like being in a grand cathedral holding a candle. You can see the nearest columns, the glittering stained glass, the ceiling arches overhead, but beyond a certain distance the walls fade into shadow. Not because they're gone, but because the light can't reach that far. The same holds true for time. There are moments we will never witness, Some galaxies are so far away that even as their light finally reaches us, they themselves have long since evolved, collided, or died. What we see in our telescopes tonight may already be gone, the light still crossing the void like a goodbye that never stops echoing. And somewhere out there, other observers, perhaps alien astronomers with eyes adapted to other wavelengths, are looking toward us and seeing an ancient Earth, one filled with dinosaurs or early forests or frozen ice ages. None of us can ever see each other's now. We're all adrift in a cosmic delay, waving at one another through the fog of time. Even our own future is bound by this. There are stars whose light we will never receive because space is expanding so fast that their photons will never catch up. Someday, far in the future, galaxies beyond our local group, Andromeda, the Triangulum Galaxy, and our own Milky Way will merge into one giant elliptical system. Everything else will fade from view, carried away by expansion until only our small island of stars remains visible. The night sky will go dark again, not from absence, but from distance. The universe will still exist, vast and alive, but it will be unreachable, hidden behind horizons that grow faster than understanding. Future astronomers, billions of years from now, might look up and see nothing beyond their own galactic glow, unaware that once, long ago, the cosmos was full of light. There's something deeply melancholic and beautiful in that thought. The universe expanding into silence, taking its secrets with it. But it's also a reminder that what we have now, this view, this window filled with galaxies, is fleeting and precious. We live in a privileged era when light from across the cosmos still finds us, when the universe is still speaking to us, still whispering its ancient story before it drifts beyond earshot. And yet, even those unseen realms, the forever unreachable, are part of the same reality. The same laws of physics, the same cosmic dawn, the same origin. Their light may never touch us, but their gravity does. Their presence shapes the structure of everything we can see. The unseen still leaves its fingerprint on the visible, so maybe, in a way, the universe is still whole. Not because we can see it all, but because we're part of all of it. Even the parts we'll never know. Let that thought settle for a moment. The cosmos hides more than it reveals, yet everything hidden is connected to everything revealed. And light, faithful but finite, will always remind us of that boundary, the edge of vision, the edge of understanding. When you gaze at the stars tonight, remember, beyond them lies more, always more. But for now, the visible universe, this shimmering bubble of light, is ours to witness, ours to cherish, ours to dream within. And now, Dylan, as the night deepens and the last edge of twilight fades, let's return to the quiet heart of it all, to the simple truth that ties every photon, every galaxy, every heartbeat together. Light is memory, and time is the language it speaks. When you look at the stars, you are not merely an observer. You are part of the conversation, one flicker of consciousness catching another across the abyss. Each star is a storyteller, each beam of light a page in the universe's diary, still being written and read at once. The act of seeing itself becomes sacred, the moment where history, distance, and awareness collapse into a single point of experience. It's astonishing how easily we forget this. We step outside, look up, and see stars as decoration, pretty faraway dots against the dark. But the truth is far richer. Each of those points is an ancient transmission, its light having wandered longer than civilization itself has existed. The photons brushing your eyes tonight might have left their homes before the first fish crawled onto land, before the continents split, before Earth even had a moonlit ocean. And they came all this way for this, for you to notice. It's humbling to think how rare that moment is, that awareness meeting the message. You are made of atoms forged in supernovae, looking back at their own origins. The calcium in your bones was born in the same kind of stellar furnace whose light now paints your night sky. You're not separate from the cosmos. You're its echo, a self-aware reflection of its own light. And in that realization, something soft and timeless awakens. The stars are not distant. They're intimate. They are your past, reaching out. Every glint above is a version of once upon a time. Together they form a cosmic autobiography, written not in ink, but in photons. There's poetry in the way light carries truth without judgment. It doesn't care if it's passing through a galaxy or a teardrop, a nebula or a cloud. It simply moves forward, always outward, leaving behind an illuminated trail of memory. Perhaps that's why humans have always found meaning in light. Candles, lanterns, suns, all of them feel like reflections of something deeper. The instinct to preserve what was, to keep it glowing a little longer against the dark. We are, in a very real sense, doing what the stars do. When we remember, when we tell stories, when we love, we too send light forward. Light that might reach someone else, somewhere, sometime. Every act of kindness, every moment of wonder, every quiet glance at the sky. They're all photons of another kind, crossing the invisible distances between souls. So maybe the stars aren't just showing us the past. Maybe they're teaching us how to exist in the present, patiently, radiantly, endlessly giving. Some of the light you see tonight left its source long before humans learned to dream. Yet it still arrives, gentle and undimmed. If that's not a miracle, what is? It tells you that nothing luminous ever truly disappears. The universe doesn't waste its light. It only sends it onward. And someday, perhaps far in the future, someone or something will catch the faint glimmer of our own existence. The radio waves, the city lights, the faint shimmer of our planet's reflection, all of it will drift through space as evidence that once upon a time, life looked up and wondered. The stars you see tonight are your ancestors past. And one day, your light will be someone else's. So as this journey ends, take one more breath. Look up one last time. Every glow above is a memory, and every memory is proof that time, though it moves, never erases. Because in the grand story of the universe, nothing truly ends. It just keeps shining, softly, endlessly, beautifully, across the night. And now, as the last echoes of starlight settle around you, let your mind rest. The universe will keep spinning, the galaxies will keep glowing, and the light will keep moving, patiently, steadily, like breath. You don't have to hold it all. Just let it pass through you as light always has. You've traveled far tonight, across billions of years, through the birth and death of stars, to the very edges of what can be seen. And yet you've never really left home, because home isn't a place, it's this. The quiet awareness of being part of something vast and gentle and alive. Somewhere out there, new light is being born. Somewhere else, old light is fading. And here, right now, you are both observer and participant. The universe gazing back at itself. So, soften your eyes. Let the constellations blur into a soft silver haze. Feel your breath slow, your body sink deeper into stillness. The stars are ancient, but tonight they shine just for you. Their light began long before you arrived, and it will continue long after you're gone. But in this moment, for this heartbeat, you and the cosmos are one and the same. Quiet, luminous, infinite, sleep well, traveler of time. The stars will keep your place until morning.